Hi, welcome to the last section of this course, more on structural patterns. With this section, we will finish with the structural patterns. We have left some of the most complex ones till the end, so that you get more used to the mechanics of design patterns and the features of the Go language. In this section, we will work at writing a cache to access a database, a library to gather weather data, a server with runtime middleware, and discuss a way to save memory by saving shareable states between the type values. Let's move on to the first video of this section that deals with proxy design pattern. In this video, we're going to create a remote proxy, which is going to be a cache of objects before accessing a database. Let's start the final section on structural patterns with the proxy pattern. It's a simple pattern that provides interesting features and possibilities with very little effort. The proxy pattern usually wraps an object to hide some of its characteristics. These characteristics could be the fact that it is a remote object, that is, remote proxy, a very heavy object, such as a very big image, or the dump of a terabyte database, or we could say virtual proxy, or a restricted access object, that is, protection proxy. The possibilities of the proxy pattern are many, but in general, they all try to provide the same functionalities, which are listed here. Hide an object behind the proxy so the features can be hidden, restricted, and so on. And provide a new abstraction layer that is easy to work with and can be changed easily. For our example, we're going to create a remote proxy, which is going to be a cache of objects before accessing a database. Let's imagine that we have a database with many users, but instead of accessing the database each time we want information about a user, we will have a first in, first out, that is, FIFO stack of users in a proxy pattern. As we are aware that FIFO is a way of saying that when the cache needs to be emptied, it will delete the first object that entered first. We will wrap an imaginary database, represented by a slice, with our proxy pattern. Then the pattern will have to stick to these acceptance criteria. First, all access to the database of users will be done through the proxy type. Next, a stack of n number of recent users will be kept in the proxy. And if a user already exists in the stack, it won't query the database and will return the stored one. And if the queried user doesn't exist in the stack, it will query the database, remove the oldest user in the stack if it's full, store the new one, and return it. So, now let's start with the unit test. Since version 1.7 of Go, we can embed tests within tests by using closures so that we can group them in a more human-readable way and reduce the number of test functions. Refer to the first section, Ready, Steady, Go, to learn how to install the new version of Go if your current version is older than version 1.7. The types for this pattern will be the proxy user and user list structs, as well as the user finder interface that the database and the proxy will implement. This is key because the proxy must implement the same interfaces as the features of the type it tries to wrap. Let me open the file proxy.go and add the package and add the interface. The user finder is the interface that the database and the proxy implement. The user is a type with a member called ID, which is int32 type. Let me replace string with int32. Finally, the user list is a type of slice of users. Let's add the lines of code for it. If you are asking why we aren't using a slice of users directly, the answer is that by declaring a sequence of users this way, we can implement the user finder interface, but with a slice, we can't. Finally, the proxy type, called user list proxy, will be composed of a user list slice, which will be our database representation. The stack cache members, which will also be of user list type for simplicity, stack capacity to give our stack the size we want. We will cheat a bit for the purpose of this tutorial and declare a Boolean state on a field called last search used cache that will hold if the last performed search has used the cache or has accessed the database. So let's add the code for this. The user list proxy type will cache a minimum of stack size users and rotate the cache if it reaches this limit. The stack cache members will be populated from objects from mocked database type. The first test is called test user list proxy, and we list it in the other file which we have named as proxy_test.go. Let's open it and add the code. This test creates a user list of 1 million users with random names. To do so, we feed the random number generator by calling the seed function with some constant seed, so our randomized results are also constant, and the user IDs are generated from it. It might have some duplicates, but it serves our purpose. Next, we need a proxy with a reference to mocked database, which I've just created. At this point, we have a proxy object composed of a mock database with 1 million users, a cache implemented as a FIFO stack with a size of 2. Let's get 3 random IDs from mocked database to use in our stack. OK. We took 4th, 5th and 6th IDs from the slice. Remember that arrays and slices start with 0, so the index 3 is actually the 4th position in the slice. This is going to be our starting point before launching the embedded tests. To create an embedded test, we have to call the run method of the testing.t pointer with a description and a closure with the function t*testing.t signature. So let's add the line of code to call the run method. For example, in this code, we give the description find user empty cache. Then we define our closure. First, it tries to find a user with a known ID and checks for errors. As the description implies, the cache is empty at this point, and the user will have to be retrieved from the mocked database array. Finally, we check whether the returned user has the same ID as that of the expected user at index 0 of the known ID slice, and that the proxy cache now has a size of 1. The state of the member last search used cache proxy must not be true, or we will not pass the test. Remember, this member tells us whether the last search has been retrieved from the slice that represents a database or from the cache. The second embedded test for the proxy pattern is to ask for the same user as before, which must now be returned from the cache. It's very similar to the previous test, but now we have to check if the user is returned from the cache. Let me add the code for this. So again, we ask for the first known ID. The proxy cache must maintain a size of 1 after this search, and the last search used cache member must be true this time, or the test will fail. The last test will overflow the stack cache array on the proxy type. We will search for 2 new users that our proxy type will have to retrieve from the database. Our stack has a size of 2, so it will have to remove the first user to allocate space for the second and third users. Now let's add the code for overflowing stack. Here, we have retrieved the first 3 users. We aren't checking for errors because that was the purpose of the previous tests. This is important to recall that there is no need to over-test your code. If there is any error here, it will arise in the previous tests. Also, we have checked that the user 2 and user 3 queries do not use the cache. They shouldn't be stored there yet. Now, we're going to look for the user 1 query in the proxy. It shouldn't exist. As the stack has a size of 2 and user 1 was the first to enter, hence the first to go out. Let's add the code. It doesn't matter if we ask for 1,000 users, our cache can't be bigger than our configured size. Finally, we're going to again range over the users stored in the cache and compare them with the last 2 we queried. This way, we will check that just those users are stored in the cache. Both must be found on it. So, here's the code for this logic. Let's save the file. Running the tests now should give some errors, as usual. Let's run them now. And here's the output. So let's implement the findUser method to act as our proxy. Let's move on to the implementation. In our proxy, the findUser method will search for a specified ID in the cache list. If it finds it, it will return the ID. If not, it will search in the database. Finally, if it's not in the database list, it will return an error. If you remember, our proxy pattern is composed of 2 user list types, one of them a pointer, which are actually slices of user type. We will implement a findUser method in user type 2. which, by the way, has the same signature as the user finder interface. Now let's add the code. So right under the user list, we add these lines of code. To find user method in the user list slice, we will iterate over the list to try and find a user with the same ID as the ID argument, or return an error if it can't find it. You may be wondering why the pointer t is between parentheses. This is to dereference the underlying array before accessing its indexes. Without it, you'll have a compilation error because the compiler tries to search the index before dereferencing the pointer. So, the first part of the proxy, find user method, can be written as I'm going to show you now. Here's the code for the first part of the proxy method. Here we use this method to search for a user in the stack cache member. The error will be nil if it can find it, so we check this to print a message to the console. Change the state of the last search used cache to true so that the test can check whether the user was retrieved from the cache. And finally, return the user. So, if the error was not nil, it means that it couldn't find the user in the stack, so the next step is to search in the database. Here's code for the search. We can reuse the findUser method we wrote for user list database in this case, because both have the same type for the purposes of this example. Again, it searches the user in the database represented by the user list slice, but in this case, if the user isn't found, it returns the error generated in user list. When the user is found, error is nil. We have to add the user to the stack. For this purpose, let's write a dedicated private method that receives a pointer of type userListProxy. Now let's add the append method below the returned statement. The addUserToStack method takes the user argument and adds it to the stack in place. If the stack is full, it removes the first element in it before adding. We have also written an addUser method to userList to help us in this. So, now in findUser method, we just have to add one line, and here's the line which I just told you. This adds the new user to the stack, removing the last if necessary. Finally, we just have to return the new user of the stack and set the appropriate value on lastSearchUsedCache variable. Also, let's write a message to the console to help in the testing process. With this, we have enough to pass our tests. Let's save this file, move to the terminal, and run the command gotext-v. You can see in these messages that our proxy has worked flawlessly. It has returned the first search from the database. Then, when we search for the same user again, it uses the cache. Finally, we made a new test that calls 3 different users, and we can observe, by looking at the console output, that just the first was returned from the cache and that the other 2 were fetched from the database. At the end, let's have a look at proxying around actions. You can wrap proxies around types that need some intermediate action, like giving authorization to the user or providing access to a database, like in our example. Our example is a good way to separate application needs from database needs. If our application accesses the database too much, a solution for this is not in your database. Remember that the proxy uses the same interface as the type it wraps, and for the user, there shouldn't be any difference between the two. In this video, we have learned about proxy design pattern.